Within this first module of our MOOC, the first chapter is addressed to present you the CO2 storage and utilization strategies in some more details, together with some related issues. As you see in this scheme, the basic idea is that the CO2 produced by the emissions of the combustion of fossil fuels can be captured and transported in some way toward other sites where use or storage of CO2 can be implemented. We have to say that this set of approaches have important roles to play the general decarbonizing global power system in order to reduce the whole pattern of emissions of CO2 in the atmosphere and to control the level of CO2 concentration in the atmosphere. This set of technologies can be very useful in enabling countries to achieve the Paris Agreement goals, for example. And it is important to underline that the basic idea underlying this approach is that the captured CO2 can be considered as a precious feedstock for industrial or chemical processes, offering strategic opportunities. CO2 cannot be seen again as a trouble, but as a commodity that can be traded and generate a revenue stream. In this slide, I presented the general approach, including the different pattern, the different utilization that CO2 can undergo. Two main lines can be taken into account related to so-called non-conversion processes or conversion of CO2. Among the first line, the so-called non-conversion approach, we can think to the use of CO2 in the food and beverages carbonated products, in the fire suppression, the CO2 used as a refrigerant or within several solvents, or in the preparation of different plastic materials, as well as CO2 has to be considered a precious component in the enhanced oil recovery approach for favoring the extraction of oils and gas. Among the different uses of CO2 in conversion processes, we have to underline the use in the different lines here represented. The conversion in the so-called mineralization process, which is aimed to favor the possibility of new construction materials to produce different carbonates material which are non-toxic and sustainable products in terms of possibility of reuse of different carbonates, as well as in the production of chemicals or in biological processes aimed to produce chemical fuels, as well as the cultivation of different algae and so on. It is also important to underline that these strategies and technologies at present under development can be used in different processes already used in approaches related to energy and materials productions. I mean that CCUS strategies can be retrofitted to existing power and industrial plants in order to reduce the impact of these processes in CO2 emissions. This will allow to reduce the emissions of different tons of CO2 in the atmosphere. And it is expected that this can allow to reduce 8 billion of tons of CO2 by the 2050. It is also to be underlined that CCUS can tackle emissions in sectors where other technologies are limited. I mean, in the production of different materials like cement, iron, steel, and chemicals, in which the well-established combustion process are required within the line of production. CCUS is also considered very important in the low-carbon hydrogen production, which will be very important for our future. And furthermore, this set of technologies will allow to remove CO2 from the atmosphere by combining it with bioenergy or through the direct air capture in order to balance the emissions that are technically difficult to be abated. CCUS has also to be considered a set of strategies for which some basic and applied science is still necessary at this level, followed by technology development, as well as industrial applications are already set up, but most of them are still under implementation. And it is also important to remember that several regulatory issues has to be set up for these approaches. As for the first line that I just mentioned, within our Comprise project, we developed different approaches regarding material and chemical processes that have been investigated. Here I remember some of them, which are an examples of different basic science which has been carried out in different university and research centers in the world within the scientific community addressed to face with these problems. We studied raw and poor materials as a possible solutions, used as a reactant for possible solutions for CO2 conversion, as well as photocatalytic based processes for CO2 conversion. We explored new materials like the metal hydride as a possible reactants for CO2 conversion, as well as more robust and metal-free solid sorbents to build new membranes for gas separation and CO2 conversion. And we also studied the possible toxicity effects of different classes of materials at present under investigation for the CO2 conversion. We also investigated what is the next step of these approaches and new studies. I mean, is it possible to think to upscale these materials and these processes approaching the market? And finally, we also investigated what has to be done for the new processes and materials under investigation for transfer the results to small and medium companies or to develop new regulatory issues for the development of interesting approaches for CO2 transformations.